Let's see how we can use the formula that we have learned in our previous video to calculate the amount to be received after a certain period of time if a particular amount is invested right now. So say I invest 1 lakh in a fixed deposit with HDFC Bank. This is not a product placement. This is not co-promotion or co-branding. I'm just using HDFC Bank because that's where I have my account. Say I invest 1 lakh rupees in a fixed deposit with HDFC Bank, which pays interest at the rate of 10% per annum. Calculate the amount to be received after 5 years, assuming that interest is compounded annually. Okay. So I want you to calculate the amount to be received after 5 years, assuming that interest is compounded annually. Now, A, that is my amount, is P into 1 plus R raised to N. Now, don't worry, I'll be having a separate session for everyone to understand how exactly do you use a regular calculator to arrive at all these numbers. Because in your exam, you will have to use the calculator. Please treat this video and this explanation only for concept building. How to quickly use the calculator and apply the same. We'll be learning that in the next video. So, my A here is going to be 1 lakh into 1 plus R. What is R? 10%. Raised to n. What is n? N is 5. Now I can quickly do a calculation here. 1.1 raised to 5. 1.61051. So this into 1 lakh. 161051. 1051. Now, what does this 161051 tell me? This 161051 is nothing but the amount to be received after 5 years if 1 lakh is invested today at the rate of 10% per annum. My question to you is, what is 161051? 161051 is the amount to be received after 5 years if 1 lakh is invested today at the rate of 10% per annum. Now I've emphasized the word today for a reason. We'll come to that in a minute. 1,61,051 is the amount to be received after 5 years. Can I say 161051 is the amount to be received in the future after 5 years if 1 lakh is invested today at the rate of 10% per annum. I'm just going to change certain words at every step so that it doesn't come as, a shock to you that a new term has been introduced. 1,61,000 is the amount to be received in the future. Can I twist this and say, can I just make some small change and say 161051 is the future value after 5 years of 1 lakh invested today at the rate of 10% per annum. So I have just now said that 1,61,051 is the future value in the future, amount to be received in the future of 1 lakh that is invested today at the rate of 10% per annum. So instead of A, can I change this to, can I call this future value is equal to amount invested today into 1 plus R raised to N. This is future value. Okay, future value is amount invested today into 1 plus R raised to N. Now I want to juxtapose a couple of words in this sentence. When I say 161051 is the future value of 1 lakh invested today at the rate of 10% per annum, what if I say, what do I want to say? 1 lakh is the value today, 1 lakh is the value today of 161051 to be received after 5 years. I can say that. Can I make one small change instead of using the word value today? Can I say value at the present, or can I call it present value? So what is 1 lakh? 1 lakh is the present value of 161051 to be received after 5 years, and rate of interest 10% per annum. So 1,61,051 is the future value of 1 lakh. 1 lakh is the present value of 161051. Can I make a small amendment to this formula? Instead of writing future value, instead of writing amount invested today, can I write down present value? Future value is present value into 1 plus r raised to n. Can I now isolate the present value on one side and write this as future value upon 1 plus r raised to n. This 1 plus r raised to n, present value into something, I transferred it to the left hand side. It became future value upon 1 plus r raised to n. So with this, we now arrive at the formula for present value. How do you calculate present value? Present value is future value upon 1 plus r raised to n, or I can simply state this as present value is future value into 1 upon 1 plus r raised to n. So divide by 2 and multiplied by 1 by 2 is one and the same. So divide by 1 plus r raised to n and multiplied by 1 upon 1 plus r raised to n is one and the same. Now we have tried to define what is future value and what is present value. Now there are two more terms that I want you to be aware of. Observe this, okay? Now, if we look at this, if we just, try to express this in a summarized manner, what I am saying is 161051 is 1 lakh into 1 plus 10% raised to 5. Now, when I multiply 1 lakh by 1 plus 10% raised to 5, I get a bigger number. When I multiply 1 lakh by 1 plus 10% raised to 5, I get a bigger number, which means, can I call this 1 plus 10 raised to 10% raised to 5 as a compounding factor? Because when I multiply by this number, the value increases. When I multiply 1 lakh by 1 plus 10% raised to 5, I get a bigger number. The value increases. I get a bigger number. The value increases. So 1 plus r raised to n is called compounding factor. When I multiply by this number, the value goes up. And when I multiply 1 lakh, or when I multiply future value by 1 upon 1 plus r raised to n, the resultant number is much smaller. So 161,051 into 1 upon 1 plus r raised to n. Here, instead of r, I can write down 10% raised to 5. This gives me 1 lakh. So when I multiply FV, that is future value, by 1 upon 1 plus R raised to N, the resultant number is much smaller. And when the resultant number is much smaller, can I say that multiplying by 1 upon 1 plus R raised to N reduces the value? And because multiplying by 1 upon 1 plus R raised to N reduces the value, I call it my discounting factor. Multiplying by 1 upon 1 plus R raised to N reduces the value. So I call it discounting factor. There is a compounding factor because 1 upon 1, so 1 plus R raised to N is called compounding factor because multiplying by this number increases the value. And multiplying by 1 upon 1 plus R raised to N reduces the value. So I call it my discounting factor. With this in mind, let's now understand how exactly is the discounting factor calculated and how does it help me in my calculations. The next discussion is focused on what are the different ways of calculating the discounting factor, the formula approach, the tabular approach, and does it make any difference if I use the tabular approach versus when I use the formula approach. We'll also see some practical implications of time value of money, that is the compounding factor, discounting factor. We'll see some practical implications of that. So stay tuned. We will come back to you with the next video very soon.